Literature. Now let's see here. So evaluate the triple integration of x square plus y square plus z square dx dy dz and taken over the value enclosed by the sphere x square plus y square plus z square equal to 1. So this all this we are changing into polar coordinates. Okay. So the polar coordinates generally in the for the circle are equal to f of t. So r equal to f of t. Okay. So this is for circle. X square plus y square equal to r square. So, but when you are coming to the spheres, the polar coordinates is this one. So, x equal to r sine theta cos pi, y equal to r sine theta sin pi, and z equal to r cos theta. And here the Jacobian is r square sin theta and x square plus y square plus z square equal to r square. So, this is then x square plus y square plus z square equal to r square. And here the Jacobian of that is become what is that r square sine square theta, r square sine theta. Okay, so dr d theta d pi. So now r square into r square, that is r power of 4. So first we are doing the integration with r. So r power of 4 integration is become r power of 5 by 5. And next to sine theta dr d theta d pi. So r power of 5 by 5, that is 0 to 1 sine theta d theta d pi. Uh, then apply the limits r equal to 1. Next r equal 0. And finally we are getting 1 by 5 is right outside and sine theta d theta d pi. Sine theta derivation integration is become minus sine theta and the limits are 0 to pi into d pi. So that is become 2 by 5 and integration of 0 to pi d pi that equal to 4 by 5. Okay. Next, here the application of multiplication of integrals. Okay. So they are asking to find that the area is enclosed by the two curves. Whatever maybe. This is a one curve and this is a second one thing. So they're asking to find the area of the region bounded by the two curves. Okay. So this is very important. The last we discussed about the volume of integration. Now today we are this topic we are discussing about that the area is enclosed by the two curves. So how we can find out that thing. Okay. So here no. So f equal f of x and y equal g of x and x equal to a and x equal to b in the xy plane. So the area of region is R bounded by the curve. This is the integration of y equal to f of x and y equal g of x and x equal to a and x equal to b. So when you are changing into polar coordinates, so the area is become R into dr d theta. So this is in the polar form. So previous one is this is okay. Now let's see the one example. 6.4.1. So find the area of the region is bounded by the parabolas. So y square equal to 4x and x square equal to 4x. So y square equal to 4x and x square equal to 4 I know. So now we need to find that the points of intersection of these two curves. So we have to solve these two equation. Then we are getting that the point of intersection. So they given that x square equal to 4a y no. So that implies that we can write squaring on both sides that we are getting x power of 4 equal to 16a square y square. X power of 4 16a square y square equal to from the equation 1 we can write 4ax. So x power of 4 equal to 64 a cube into x. So from here take x is common. So that we are getting x equal 0 or x equal to 4a. So next when x equal to 0, then y equal to also becomes 0. Then when x equal to 4a and y equal to 4a. So these are the two curves are intersecting at the origin and they are intersecting at the point 4a comma 4a. So therefore, we can find that area is bounded by like this here. So we can find that area in between of these points only. We can find that area of the region. Okay, so this is 0 comma 0 and this is 4a comma 4a. Now the area formula is the double integration of dx dy. So the region is R is covered by that varies from x from upper curve to lower curve, and y is varies from 0 to 4a. From these two equation, we can find that x values. So that is y square into 4a. So when we read the x limit, so we have to draw the line parallel to the x-axis. So when you are drawing the parallel to the x-axis, when it is meeting the first curve, this is okay, and the exit and this is. So this is entry and this is the exit. So that we can find the x limits. So after finding the x limit, then we have to substitute dx dy. No? First we are doing the integration with x. Then integration of integral of 1 into dx is x. Okay, now apply the limits and that integration of apply the limits. After that, we are getting 2 into root a root y minus y squared by 4a. So at the end of, we have to do the final integration with y. So when you are doing the integration with y, so root pi is nothing to y power of 1 by 2. So y power of 1 by 2, that is integration is become y power of 3 by 2 by 3 by 2. Okay, next y square integration is y cube by 3. So then we need to apply the limits 0 to 4a. So after the simplifications, and we are getting that 16a square by 3. So when in place of y, we have to substitute 4a, and next minus in place of y, we have to substitute 0. Then we can find that uh, area of the region enclosed by the two curves. Okay. Now here the one problem is there. So x square equal to y and y square equal to x. Okay. So x square equal to y and y square equal to x. Then value we can find these two curves. Same, just now we solved all the problems. So same thing we need to find out. Okay. And this is that area bounded by the two curves. Next, volume as a double integration. So actually the volume we are finding in that triple integration only. Okay. But some cases we can find out that the volume in double integration, and using the double integration, and we can find that integrations. Okay. So find the volume of the tetrad bounded by x by a plus y by b plus z by c equal to 1 and coordinate planes. So x by a plus y by b plus z by c equal to 1, no? So from there we can write z equal to we can write c into 1 minus x by a and y minus b. Now this is the z is a function is become f of x comma y. So from there we can find out that uh, z we can find out that area of the region. So here this is the z equal to c of 1 minus x by a minus x by e, that equal to f of x comma y. Okay. Now that volume of the region z into dx dy. So already z is means what is that? C into 1 minus x by a minus 1 by a dx dy. So the equation of the intersection of the given surface with the xy plane is x by a plus y by b equal to 1. And here we need to find the limits of y. So if you need the limits of y, means you have to put from here we can write y equal to b into 1 minus x by a. And if we need the limits of x, means you need to find, you need to substitute that x equal to 0. Then we are getting y equal to 0, y limits and x limits, and we have to substitute here. So after the simplification, and we are getting that a comma b comma c by 6. So this is that volume of tetrahedron using that double integration. We can find the triple integration also. We can get the same value, but they are using the x limits are 0 to A, and Y limits are 0 to B, and Z limits are 0 to C. Okay. So this is the, yeah. Thank you.